Next, having discussed units of surface and volume, we're going to look at fractional units. So this is going to be something like miles per hour that you can imagine. But, well, we're going to stick with the metric system for right now. We will switch between metric and imperial systems soon enough. All right, first example. Okay, we have a pool, and the water in the pool has a density that is 1 gram per centimeter cubed. We want to express that in kilograms per liter. Okay, and then just remember that hint, and that is something that I'm not always going to give you, so make sure to get that in your notes. That 1 milliliter is the same as 1 centimeter, which is the same as 1 cc cubic centimeter. Okay, here we go. So we're going to start with this, this density, okay, and a density again. Sometimes you use rho, RHO, sometimes you use D. It depends on your context, okay? And in any case, we don't really care about the symbol. But we're going to begin with that density, 1 gram per centimeter cubed. And if you want to put a 1 there, that's always fine. All right, so now I need to convert, okay, let's see, I want this in kilograms and liters, right? Okay, so let's do these one at a time. So I'm going to convert the grams to kilograms. Okay, so if I focus on just the grams for the time being, I want grams to cancel out and I want to be left with kilograms. So we know in 1 kilogram there's 10 to the third grams. Okay, and then with that, the grams are going to cancel out. And if I were to multiply this through, I would be in kilograms per centimeter cubed, right? But I don't want centimeter cubed. I want liters. So, okay, let's focus on the centimeters cubed. I can just continue the multiplication. Or again, if you want to multiply and restart, that is fine as well. In any case, we have centimeters cubed, and I'm going to use the hint. So 1 centimeter cubed is 1 milliliter. So that'll cancel out the centimeters cubed. So now I'm in kilograms and milliliters. Right? So I don't want milliliters, I want liters, so okay, change milliliters into liters. Okay, 1 liter, there's 10 to the third milliliters, and then the milliliters will cancel. Okay, now if I multiply through, I'm in kilograms and liters, which is what I want. So I'm just going to stop dimensional analysis here and do the mathematics, multiply through. Numerator, 10 to the third kilograms, and then the denominator is 10 to the third liters, and simplifying, this is just 1 kilogram per liter. Huh, that's nice, and kind of interesting, and actually a nice property of water. Okay, density is 1 gram per centimeter cubed, or 1 kilogram per liter. Okay, next, so this is one example. This next example is a little bit more involved. Okay, we borrow this example from physics. Okay, we're not always going to be dealing with just mathematics or chemistry. We're going to be doing unit conversions in physics quite frequently. And so I just want you to pause the video and read this through before continuing. Okay, so now this might seem like a little bit of a daunting task. You might not know where to start. And really where to start is actually the last parenthetical comment. Product of mass and acceleration. Okay, so I know I need to report force, right? That's my final answer. And so I need to find mass and acceleration. Okay, and I think if I look closely right here, this is a mass, right? It has units of grams. And while I need an acceleration, it's another number. Acceleration is going to be the other number that's given to us. Okay, but now I have to kind of take a close look at this. I need to report force in this Newton's unit. Okay, and it says that Newtons are, like 1 Newton has these units, kilograms, meters, and seconds squared. So I need to go ahead and convert as needed. So I need to convert the mass from grams to kilograms. Okay, let's do that. So mass is 1.5 times 10 to the 6th, which if I, grams, and if I change that into kilograms, okay, here we go, 10 to the third grams per 1 kilogram. All right, 1.5 times 10 to the third kilograms. Okay, not too bad. Next, acceleration, if I look at that, okay, there's kilograms, meters, I have kilometers, okay, convert that, and seconds, I have hours, convert that. So this is where we have 2 things to convert. 18.6 kilometers per 1 hour squared. Okay, this is going to be interesting. Let's focus on kilometers first because that's a little bit more straightforward. 1 kilometer, and I need to convert that to meters, 10 to the third. Okay, so that strikes that out. But now I'm in meters per hour. I need to be in seconds. So I'm going to convert hours to seconds. And this is something that you might need to look up. If you want to go hours to minutes, minutes to seconds, that's fine. But there's 3,600 seconds in 1 hour. Okay, and now you would think you'd be done and you could just cancel hours, but notice there's a square unit, right? So I need to square this. Okay, or I would multiply by it twice. Okay, and then after this the hours will cancel. Okay, and now we go on and do the calculation here. Doing this on a calculator yields 1.44 times 10 to the minus 3. That's if you were to do that using scientific notation. And then the units here would be meters per second squared. Okay, because meters, and then we have seconds, but we have 2 of them because we have a square there. Okay, and then now finally, okay, so I've found the mass, I found the acceleration, and then force. It's saying that to get the force, I just have to take mass times acceleration, which is 1.5 times 10 to the third times 1.44 times 10 to the minus 3, and I'm approximating this as, when you do the math, 2.15 newtons. Okay, so again, the whole scheme here is to just take things bit by bit, and there might be a lot of information thrown at you. Look at each number that you're given, identify what number or what measurement is associated to it, and then take that unit and convert it as needed into whatever units are being asked for. So mass so from grams to kilograms, and then kilometers to meters, and hours to seconds. Okay, and then at the end we just have to put it all together by the description of the English description that's provided to us. So we will get some more practice with this in class.